we'll start our session with the difference between the binary tree and a tree, right? So as you know, the definition of a tree is it does not impose any restriction on the number of children it should have. So a tree can have any number of children, right? Except that particular restriction, everything is similar to that of a binary tree. In fact, we can say that a binary tree is a tree with a restriction saying that most of the nodes, not most of the nodes, almost all the nodes should have at most 2 children. At most, in the sense, I have already told that at most means every node can have either a zero children, 1 children, or 2 children, right? So with that, a quick recap of the yesterday's class. Let me start our discussion with the difference between the tree and a binary tree, right? So the first definition, according to the definition of a tree and binary tree, we can have the first comparison point. That is the first point. What we can say is a tree does not have any restriction on the number of children. And the second point is, but a binary tree can have at most 2 children, right? So that is the first difference between a tree and a binary tree. Remaining thing is same. And coming to the second difference, the binary tree is said to be ordered in nature. Ordered means, as I told that every node in the binary tree can have 0 or 1 or 2 children, right? So if it has 1 children, it can be either treated as a left child or a right child. Similarly, the children of a particular node can be divided into 2 categories. That is, either it can be a left child or it can be a right child. But in trees, as there is no restriction on the number of nodes, as there is no restriction on the number of children for a particular node, what we can do is, there is no distinction of either a left child, middle child, or right child. This also we have discussed yesterday. But here we can say that the subtrees of a binary tree are ordered in nature. For example, if you look at the screen, we can observe 2 different trees that are given. Okay, this can be a tree. This particular thing can be a tree. And this is also a tree. Why? Because one node is designated, that is A is designated as root node, right? And the node is having the children like B. Similarly, this particular tree is also having the children B, right? So it is a tree. And how can you confirm that it is a binary tree? It is a binary tree also. Why? Because it has 1 children. Therefore, the degree of this node is 1. Similarly, the degree of this node is 0, and the degree of this node is 1, and the degree of this node is 0, right? So everything appears to be same, like it appears as a tree and as well as a binary tree, right? But the difference is, if you look at these 2 trees, this is the first tree, the first category, and this is the second category. If you look at these 2 trees, we can say that there is a ordering in the binary tree. If you treat these 2 trees as a binary tree, we can say that A is having a left child as B for the figure 1, right? This is figure 1 and this is figure 2. And if you look at figure 2, we can say that A is having the right child, right? But if you treat these given figures or given examples as a tree, we cannot say that A is having B as the left child and A is having the B as the right child. Why? Because we don't have any distinction in the case of the trees, right? So we can say that a binary tree is ordered in nature. That means a binary tree is ordered in nature. That means we can distinguish a particular node saying that it is having a left child and it is having a right child. But it is not possible. Therefore, we say that the tree is not ordered, right? Next. So the same thing what I have explained here, you can see that they are different when viewed as binary trees. Why? Because this particular figure in figure 1 is having the left child, whereas in figure 2 it has a right child, right? And but it is same when viewed as trees. So the concept here is, when you view these 2 figures as trees, they are one and the same. But if you view these 2 trees as binary trees, then they are different. So this is one of the important difference between a tree and a binary tree. And one more difference we have already known with the definition part, that the tree does not have any restriction on the children, but a binary tree is having a restriction on the children, saying that every node can have at most 2 children, right? So the second point is already discussed. A binary tree may be empty. This is another important point, right? A binary tree may be empty, but a tree cannot be empty, right? And this is we have discussed. No node in a binary tree may have a degree more than 2. That's what we have discussed. Every node in the binary tree will have a degree of at most 2. At most 2 means 0, 1, 2. Whereas there is no limit on the degree of the node of a tree, right? This also we have discussed, that the tree does not have any restriction on the number of children, right? Similarly, the same example which we have seen in the previous slide, the subtrees of a binary tree are ordered, right? Ordering means we can say that we can distinguish the left child and the right child, but a tree is not ordered. That means there is no distinguishing of left child and right child. For example, if you take these 2 trees, so if you consider both these examples as trees, there is no difference. Why? Because they are not ordered. But if you consider these 2 figures as a binary tree, there is a distinction. That means A is in the first figure, A is having the left child as B and the right child as C. But if you go to the second figure, you can clearly observe that A is having the left child as C and A is having the right child as B. So here in binary trees, the nodes are ordered in nature, and whereas in trees, the nodes are not ordered.